First take. Hi guys, my name is Hrithik, and today we have our first professor on the show. His name is Professor Stéphane Somé, and he's actually the Associate Director of Software Engineering here at uOttawa, and he's the first prof I had in my first year, so it's pretty cool to have him on the show. And today we'll be talking about his research, how he likes teaching at uOttawa, and things such as how he got into software engineering, why he chose to do research, and how, if you want to do research, how you guys can get involved with that. So let's get on with it. Thank you for coming in today, Professor Stéphane Somé. It's really good to have you. You're the first professor on this show, so I'm really excited to see what comes out of this. Would you like to tell the audience a little bit about yourself?
Yes, thank you for having me, and it's really a pleasure to be able to address people, particularly future students who will want to know a little bit about us. My name is Stéphane Somé. I am associate professor at ECS, formerly SITES. I've been in the Faculty of Engineering for 20 years now. And before that, I was a research associate for 2 years, working with an industrial project. And before that, so before coming to Ottawa, I completed a PhD in Montreal.
And that was in computer science?
In computer science, yes.
Okay.
Because at that time, really, software engineering was not a discipline on its own, let's say. Then, yeah.
Okay. So, Professor Somé, how did you choose to pursue software engineering?
That's a long story. Let's say growing up, really computers were not the big thing. So when it came time to go to university, that was it was completely new to me. And I found the logical aspect of computer science very interesting. So that's what actually brought me to computer science. And then during my studies in computer science, I got more interested with issues that have to do with software engineering. At that time, I say it was not really a completely separate discipline as such. So I end up specializing in issues that have to do with software engineering, just because they were the ones that were interesting to me.
Okay.
Yeah.
So the next next topic I want to get into is, a lot of the times, especially on YouTube, what most people cover is how to get how to work at one of the big four, or how to get an internship at, or how to start their own startup, right? But on YouTube, they don't really cover how to get into research. If you're in software engineering, how would a person get into research, right? So that's one of the things I want to promote on this channel, is that in software engineering, one of the aspects that you can go down is also research. And it's a very interesting field to work in. So you're a professor, you do research of your own. I want to know why you chose to do research.
Yeah, so that's a very good question. Research is give the opportunity to dig deeper in any area, like an area of interest, let's say. So research is very good for anyone who's interested, who is curious, who is want to go beyond, basically what they learn in textbooks and in class, and start contributing to the body of knowledge themselves. So in my case, usually, and again, that's usually the case for a lot of people that I know who end up going into research, it's just seeing some problems and seeing that there's no obvious solution to those problems can bring the first the idea and then for the need to actually find a solution, And this end up, when obviously it's an interesting problem, this end up putting us in the path of some research work. So for instance, in my case, like in my particular case, how I went to start working on a PhD, it's because, I learned about the software engineering process. So we have to capture requirements, and then we have to model these requirements in design, and then implement, and so on. But one big problem is the path. How do you go from those requirements and make sure that the design actually corresponds to the requirement, because the process is manual. Okay. So this problem actually made me think, okay, can we do these kind of things more automatically? Can we find tools and approach and method to do that?
Okay. So if a student wants to do research, right? He wants to pursue like maybe a PhD and then do research after that. Mm-hmm. What do you think? So let's say he's in his first year or second year. What are some steps he can take so that, or he or she can take, so that they can get into research?
I'll say there are a lot of opportunities actually to start on the path to research even from first year. We have programs like Europe that you can get some funding, some scholarship to work with a professor in the lab. Even without those initiatives, says anybody interested in research, it's just a matter of approaching a prof. Obviously learning a little bit about what this prof is doing as research, and asking to join their team during the summer. Could be a co-op work too, because we get some co-op that are partially, like kind of funded by research, and so it could be a co-op, could be Europe, and I'll say, if you are curious, if you want to learn, if you want to go deeper in any subject area, research is for you.
And are you accepting like assistant researchers or anything, or do you know what the process of that is like? So if, let's say I know you're a professor, right? If a student knows a professor, what is the best way for them to work with them? So should I just go up to you and be like, I'm really interested in research, I have so-and-so experience, I'm interested in so-and-so things?
Yes, that would be the first step. The first step would be to go to the professor. Okay. To, I'll say probably maybe before that, read a little bit about the professor research on their website to see their area of work. Mm-hmm. And if this area matches your interest, send them an email and go talk to them. Okay. I'd say most professors would be happy to have a student for this, during the summer, to help in the research lab and to help with the graduate students. So yeah, this also provides a better way to jump into a master's and then a PhD at the end of the when times comes, let's say.
So could you tell us? I know that you do research on. You said verification and requirements. So could you tell us a little bit about your research in that field?
In the requirement field, that's actually what I did starting my PhD work, and also a few years after that. For the requirement, the big requirement problem is this gap between requirement and design. Okay. That we capture requirement and then manually create model from those requirements. So there is always no certainty that actually what we model is what we capture. Okay. And we know that this is one of the leading problems later on in the software development cycle. So my work was about, okay, how can we automate, let's say, the creation of models from requirements, knowing that those requirements to be consider as requirement must be understandable by stakeholders, by users. So they need it to be captured in some languages that is close to the natural language. So there were some natural language processing there in that work, and also some derivation of models from those natural language type of requirements.
So how similar are these requirements to what we learned in SCG 2105? So I just had that course, and we learned functional requirements, we learned quality requirements, right? So one of the functional requirements could be the system should have all the users log in through a welcome page, right?
Yeah.
That could be a functional requirement.
Yeah, exactly, that's a functional requirement.
So is your work helping, is your aim or purpose to help, I guess, the developer understand what that requirement is actually wanting to do, or is it something else?
Yeah, that project I'm talking about was actually the formalism for capturing requirements with use cases. Mm-hmm. So if you use cases, you can capture functional requirement as a different interaction step between an actor and the system.
Okay.
Now, at the end of the day, you want to make sure that if the actual, if let's say you create a state model representing the behavior of the system, mm-hmm. You want to make sure that the state model reflects the use cases that you had at the beginning.
Okay.
And you also want to check other properties like the completeness of the use cases. Do we have gaps that need to be filled with more use cases? And you also want to be able to exploit these use cases, for instance, to create test case and so on. So for that, we needed to formalize the use cases. Okay. So we needed to have some, but formalized by still keeping them at the level of end users. So end users can read the use case and understand them.
Why do you think it's so hard for developers or engineers to stick to the design requirements?
Because it's a communication issue to start with. Requirements are expressed by end users, by clients, by customers, and you need to process this. So developers need to take this and process. Mm-hmm. So there's always a communication problem. Okay. And as for any communication problem, there could be some misunderstanding. There could be some assumptions that are made by one party and that are not communicated the right way to the other party. And there could be also, because usually you also, for large system in particular, you can have several stakeholders. So you can also have a situation where one requirement from one stakeholder is contradicted by another requirement by another stakeholder. So this is the reason why it's for large system particularly, it's always it makes it very difficult for developers to ensure that at the end of the day they have the real system. An additional thing, obviously, it's not to miss is the fact that the requirement change too. Actually, for the same stakeholder, the requirement that were communicated at the beginning of the project are likely to be completely or to have a substantial change by few months in the project. So there is this catch-up that needs to be done at all the point. So all of these are what actually creates some of the big problem with software engineering.
Is there so I was just thinking, is there a way for, I don't know, is there like a solution where, or like, I don't know, maybe like a AI or some kind of machine learning solution where the bot or whatever, it keeps track of the code and keeps track of the documentation, and based if it looks at the code and compares it with the documentation, and if it sees a difference, it like outputs a certain percentage for like this is how much your code and documentation differ by, or it automatically updates the documentation based on how the code looks like. Is there a software solution for that, or is that something you're doing?
Well, that's really interesting. Wow, I think I can see a research project there actually from what you're saying. I know that there are some use of AI for reverse engineering, for instance, trying to understand change logs, and based on the change logs to get some prediction or to attach that to code. So there are different work, different research work have been done on applying machine learning AI techniques to the problem of reverse engineering. The particular approach you're talking about, I'm not familiar with it, so that's what I'm saying. I think it's really maybe you have something there that can be worth looking at. And again, this is, as I was mentioning before, this is how usually sometimes research ideas can come, and then you start digging in, and sometimes you can end up saying, oh yeah, maybe someone already attempted that, but no, sometimes it's absolutely new and it's worth doing. Yeah.
So we didn't talk about the other side of your, I guess, research is the professor, right? You're also a professor.
Yeah.
So how do you find teaching university students? Do you enjoy teaching, or do you find that we can be really annoying and that you dread teaching us and you rather just do research?
No, I personally like teaching.
Okay.
I think teaching is, if I have to put together both research and teaching, I tend to prefer personally teaching.
Okay.
And even in our domain, it's you still have to do some research just to teach, because you have to remain current. You have to so there is this motivation there. There is this it's never boring task. It's never so and I like the communication. I like to see students learn new stuff from me. It's kind of it's satisfaction. Like I'll say no. I personally enjoy teaching. Yeah.
And I know you teach courses here. You teach I think you teach software quality assurance, right?
Yeah.
And then you also teach, I think there's SEG3.
Software design.
Yes, that
Yeah.
one. Software design, and then you also do the first year SEG 2900.
Yeah.
But you have more on like a laid back role in that class.
Yeah.
So do those two courses relate back to the research you do, or is it that you're more passionate about those two courses?
No, those two courses relate to aspect of my interest in research.
Okay.
And this is also usually the case for most professors. I say the software testing, software quality assurance has to do with testing and aspect in general related to making sure that we build the right software for for the task. And software design and architecture, yeah, I'm doing stuff that has to do with, as I mentioned previously, like basically design from requirement, how to move from requirement to design. Yeah. So they keep actually, I mean, this aspect, being able to teach what you work on on the research side is one of the very interesting and very good aspect of this both research and teaching job, because you can you learn more from research that you can pass into the teaching side, but at the same time your teaching also provide questions that you can dig deeper on, like on the research side.
Do you feel that with because software is changing very quickly, because with the change in technology, do you feel like some things in the curriculum right now should be omitted and some other things should be added? Or do you think the structure we have right now is very good for the real world? It prepares us for the real world very, very well. So do you think we should keep it as is, or we should update it as with the rate of technology?
Yeah, I think that when we talk about the program, there are different things. There are courses that are defined broadly, like they are defined in terms of objective, learning objective and learning topics that need to be done there. Now, the content of the course itself evolve. Because there can be a new method, new tools, new approaches. So the content of the course itself evolve within that. So regarding that, I think the structure itself is okay. It's good. Now we can obviously from time to time we introduce new courses when needed. When, for instance, just a few years ago, there was no mention of cloud computing. So now we have cloud computing. So sometimes when we don't see any room in any course to actually discuss this important topic, we can introduce new courses. But we have to work within some boundaries, because it's we have accredited programs, so we have to respect some constraints, like in terms of accreditation, and there are also body of knowledge or general curriculums that are guidelines for curriculums that are typically defined. That are also good inspiration for our own design of our program, or our own adaptation of basically.
So if you want to learn more about Professor Somé, you can connect with him on LinkedIn, or you can look at his website, or you can actually see some of the research he's done. So we'll have all these links. So we'll have his LinkedIn link, his website link, and then a Google Scholar link to see all his papers. It'll all be in the description below. Thank you so much for coming today. I really appreciate you taking some time out of your day. It was really interesting to see, I just had the SED 2105 course, right? And then seeing that your research actually impacts what I've been learning, it's really interesting to know that the things we learn in class actually can be applicable in the real world. So thank you for coming out today. Yeah.
Thank you for having me, and it's a big pleasure to talk to exchange and talk a little bit about the stuff that we do. Again, I encourage everybody who is interested in research to let the curiosity go. That's really that's the important thing.
All right, guys, that's it for this video. This was our first professor video. We're gonna probably have more coming shortly. So if you want to see more, like, subscribe, and hit that bell icon. That's it for this video. Bye bye.